Hello, everyone. We are going to spend some time in this video introducing the concept of expected value. And so I'm on page 9 in our section 2 note packet. And just to give a little, contextual example, we could think about that shiny Pokemon example that we used earlier to introduce the geometric distribution. And in that context, we only really considered, various probabilities of, probability of encountering it on our first, encountering a shiny Pokemon on our first trial. But a natural question to consider is how many times or how many Pokemon a player can expect to encounter before encountering their first shiny Pokemon. And so this lends itself to the idea of expectation or expected value. And so we'll use those two terms interchangeably. And to have a concrete example to introduce this concept, we're going to consider this example about a hospitalization from a certain illness where we have this probability distribution function of x is equal to 6 minus x divided by 15, where x can be 1, 2, 3, 4, or 5, and x is the number of days of hospitalization. And so again, a natural question is how long should someone expect to be hospitalized? And there are a couple ways that we could think about this expectation. And so first, the expectation we can think about as a long-run mathematical mean of the outcomes of the random variable x. And so this is not like a sample mean in Stat 113 because we don't really have data that we've collected on this process. But it is more like a center of this distribution, which we can find as a weighted average of the possible values of x. And so we'll see how this works for this particular example. The weighted average here, as you can see in the definition of expected value, the weights are actually the probabilities that the values of y or x, or however you've defined your variable, so the probability that those particular values are going to occur. And so what will happen is we will end up giving a higher weight to values of the random variable that have a higher probability. In this example, we can find the expected value of x. So I'm just going to use this formula where it's saying to sum over all the values of x or y multiplied by their probabilities. And so here, e of x is going to be 1, because that's the first value that x can take on, times the probability that, times its associated probability, so 6 minus 1 divided by 15. I'm grabbing that from this PDF, plus 2 times 6 minus 2 over 15 plus 3 times 6 minus 3 over 15, and you could kind of make out the pattern of what is going on here. Again, they are the values multiplied by these weights that come from the probability distribution function. So we're going to give values that have a higher probability more weight in the expected value because these values are more likely to occur. If you do this calculation, you wind up with 2.333 days. Notice that this is not 3. So it's not the same as just doing 1 plus 2 plus 3 plus 4 plus 5 divided by 5. And the reason that it's not the same is that in this particular example, smaller values of x have higher probabilities and more weight. So that's why the actual value is lower than 3 and is just 2.333 days. Again, we'll see lots more examples of expected value in class, but you should now have enough info here to hop onto Canvas and complete the short quiz on expectation.